could not understand last session, you don't have to join today's session because I'm going to repeat the same topic. Maybe, right? So few maybe I'll be repeating couple of other things. Okay. Okay, give me a second. So we discussed about linear regression the last session. So linear regression, one of the very simplest machine learning model. So what exactly linear regression all about, and why do we need to use a linear regression? That is what we are going to look at it now. So for example, right, so what is a linear regression? Okay, to start with, let's understand what exactly linear regression. So why do we need to use a linear regression? The linear regression is used to solve the regression problem. What is regression problem? To solve the regression problem, we use the linear regression algorithm. It's also a statistical method. It is an algorithm, machine learning algorithm, right? So it's all same, okay? To solve the regression problem, we are using the statistical method or the algorithm. Regression problem. What is the regression problem? Anybody remembers this? Yes, you are correct, right? How about others? Yes, you are correct. Anybody else wants to make a try? What is a regression problem? Regression problem is a type of supervised learning task, right? The goal of the regression problem to predict a continuous numerical outcome variable. To predict a continuous numerical value based on one or more input variable. To solve the regression problem, we can use linear regression. So, but that doesn't mean to solve the to solve the regression problem, we can use only linear regression. Like linear regression, a lot of other algorithms are available. Okay, using which also we can solve the regression problem. Usually, as part of the regression problem, we start with the linear regression model or linear regression algorithm. Okay, so what exactly the regression problem is all about? To predict? Yeah, it's a type of, right? It's a type of supervised learning task. So if I say regression problem, obviously it falls under supervised learning, isn't it? That's what we discussed at the past session. In the supervised learning, there are two types we have seen it. One is the regression problem, other one is the classification problem. Here, in the case of regression problem, the objective of the linear regression model is to, the goal. So the goal of this, the goal, the goal of this algorithm is to predict a continuous variable, continuous outcome variable. Predict a continuous outcome variable. That is the goal of using the linear regression model. What do you mean by continuous outcome variable? You know what is a ratio and a continuous variable, right? Sorry, yeah, the discrete variable, continuous variable, we discussed it already as part of discrete statistics. Okay, you want to predict any, or let's put it simple, to predict a numerical outcome variable. The classic example, I want to predict the housing price. So in that case, the goal of this algorithm is to predict the housing price. The outcome variable is outcome price. What is the outcome of this model? The outcome of this, sorry, the goal of this model. This goal of this algorithm or the model is to predict a continuous numerical value or continuous outcome variable. Housing, for example, I want to predict the housing prices. I want to predict the temperatures based on one or more features. How do I predict housing price? Based on one or more features, input features. Okay, if I ask you to predict an housing price, how will you predict an housing price? For example, in Adyar, in Chennai, if I ask you to predict an housing price, what is the first question that you will ask? Okay, so you want to buy an house in Adyar. You want me to predict an house price of Adyar, right? So in that case, can you please give me the square feet of the house? What is square feet of the? That is your input feature. Using the input feature, in this case, the square feet of the house, we are going to predict the numerical or the continuous outcome variable housing price. So the goal of this algorithm is to predict a continuous outcome variable. Okay. So linear regression falls under the regression problem. To solve the regression problem, we use a linear regression, and it's a type of supervised learning task. The goal of this algorithm is to predict a continuous outcome based on the input features like size of the house, age of the house, location of the house, and so on. Okay, and also one of the key objective of this one is to model the relationship between. One second. Second. Model the. This is important point. Relationship between dependent and independent variable. Dependent and independent variable. Model the relationship between the independent and dependent variable. One second. I just. No, the question is what exactly modeling the relationship between the dependent and independent variable. So what do you mean by dependent and independent variable? How many of you remember this? Dependent is your outcome variable, okay, and independent variable is input features. So you might be asking this, why the hell are you using different naming conventions? I'm getting confused. So because if I use the different names for the same term, right, you will be able to understand when the customer, because you cannot expect the American customers or UK customers when you are working in a project, right, to explain what exactly, or you cannot dictate them here. Don't say independent. I get confused. Instead, you say outcome variable. You cannot tell them, right? And also, you cannot tell them don't use the term independent variable. Instead, you can use input features. What if the customer uses these terms at the time of explaining the project or reviewing your code, right? So in that case, you should be familiar with all the terms related to the linear regression model or machine learning model. Okay, so in the input features are nothing but independent variables. The outcome variable is nothing but dependent. These are the synonym to this one. Okay, outcome variable is synonymous to dependent variable. Input features are something like synonymous to your independent variables. But most of them they use this term only. Okay, the input feature. Feature means input feature. That's all. Okay. So model the relationship between dependent and independent. What exactly modeling the relationship between these two variable? Modeling the relationship between these two variable. What do you mean by these two variable? The input and output variable or independent and dependent variable. Okay, now this is the question. What do you mean by modeling the relationship? Yes. No, you are partially correct. Okay, here, this is what I explained in the last session. I think most of you have forgotten it. 1 second. But that's what. The same topic in different, like in the exam, you know the answer, but the question is tricky. They ask the question different way, right? So that is, that is what the situation now you are in. Don't worry. So what do you mean by modern the relationship between dependent and independent variable? There is nothing but 1 second. I'll just copy paste it. Okay. Here, the idea here is, okay. So we are, see here the idea here is how much change in X influence Y. That is what modern relation. How much change in X influence Y. Or I just type it in here, okay. How much change in X influences the Y. How much, that is what. For that reason, we are modeling the relationship between both the input and output variable using linear regression model. Okay. How changes in X, instead of saying that how much change, how, instead of saying, yeah, we can say, how much change in X. Okay. Or otherwise, how changes in X influences the Y. So what do you mean by influence, changes in X for example, if the square feet is 500, what is, how much the price value, how much, it will influence your Y value is housing price, X is your square feet. How much changes in square feet will influence the um, housing price? Okay. Is that 2 times will that influence your housing price? Okay, or 3 times will that influence your housing price? Something like that. So that is the one you can understand using the linear regression model. That is the beauty of linear regression algorithm. Got it? That is the whole idea of using the linear. So now you need to first understand the big picture very clearly. How changes in X influence the Y. Okay, for that reason, we are modeling the relationship between the independent and dependent variable. That's the reason why we are doing this one. Got it? So how it is possible to solve the or how do I predict the housing price? Okay, how do I predict the? So before that, we discussed about the types of linear regression model. We discussed about initially in the past session the different types of supervised machine learning algorithm or types of machine learning algorithm, and within the supervised machine learning algorithm, we have explored two types of supervised machine learning problem. One is regression problem, other one is classification problem. Within the linear regression, so there are two types. One is simple linear regression, other one is multiple linear regression. Okay, in the case of simple linear regression, we'll be using only one independent variable. It can be anything. Okay, we'll be using only one independent variable. Whereas in the case of multiple linear regression, we'll be using more than one independent variable. Okay. Okay. I told you what is the object, what is the goal of this one? The linear regression model. Okay. Okay. What is the objective of this one? Objective of this model? I'll put that one also. I'm going to add on the objective. The objective of this model is to find the best fitting is to of this Model is to find the best fit line. Is to find the best fit line. What is best fit line? We discussed in the last session. Model is to find the best fit line or fitting the straight line here in simple linear regression. You can say this way, fitting the straight line. That is what is linear regression. In simple one-liner, fitting the straight line is nothing but the linear regression algorithm. Okay. So now we understood what exactly linear regression is all about. The algorithm is all about. It is a statistical method. It is also called as a linear, sorry, it is also called as a machine learning model, or it's a machine learning supervised, model, supervised machine learning model. We can say that way. Okay. Okay. Now the question is, so what exactly the two types of linear regression models? One is the simple linear regression. Other one is the multiple linear regression. So as we say, as the name says, simple linear regression. In that case, we are going to have a single independent variable. We are not going to have multiple independent variables. Okay, I just 1 second. There are two types of linear regression. One is simple, and the second one is multiple. Simple linear regression, multiple linear regression. Okay, what exactly the simple linear regression is all about? So it in this case, y is equivalent to beta naught plus beta 1x. This is what your simple linear regression model's equation. First, we understood the big picture. What is the linear regression model, and why do we need to use the linear regression model? What is the goal and objective of linear regression model? We have seen it. Next one is the equation for the model. Okay, here the beta naught plus beta 1x plus, yes, right, E is error. So what is beta naught and beta 1? What is beta naught, beta 1? It is intercept. It is called your intercept. This is called your slope. Okay, and what is x? X is my independent variable. X is my independent variable. Okay, and what is E? Error term. E is the error term. E is the error term. Okay, now we got clarity. Okay, what exactly y? Y is my dependent variable. Dependent. Why it is called dependent variable? For example, in the case of housing price, I want to predict the housing price. Housing price depending on what? Depending on your size of the house. Right? Size in terms of square feet. Here, this variable housing price is depending on the size. That's square feet. Based on the square feet, the housing price will also, either increase or decrease. For example, if the size of the house is 1,500 square feet, the housing price will be more. When you decrease it to 500 square feet, obviously, this one will be less. Okay. So first of all, to predict an housing price, you need to have this basic information. What is the square feet of the house? Okay. So this is your independent variable, and this is your dependent variable because the housing price depending on your size of the house. Okay, now you understood what is the equation. Y is equal to beta naught plus beta 1x plus E. Okay, now you understood the equation. In the case of multiple linear regression, the same equation, but you will be having more than one independent variable, and beta 2 x2 and so on. Okay, here the same thing. This is your intercept. This is what? This is your slope of the independent variable x1, and this, here also slope. This slope is for your for example, this is size of the house and this is age of the house. Okay. Here, this slope is for the age, and this slope is, for the size, right? The size, the independent variable size, the corresponding slope is this one. For the age independent variable, the corresponding, the slope is beta 2. The slope 1 and slope 2 and so on. So if you have more than one independent variable, we call that as a multiple linear regression in your model. Is it clear or not? Okay, good. Anybody has any doubt here? You're going a very slow pace. Yes, very good, Shauru. Okay, this is the one, right? So beta 1 and beta 1. Yeah, this is the one. Okay. So next, what are we going to do now? Now, we will see what exactly intercept is all about. First, I started with the big picture. Now we understood the equation for each type of linear regression. So it's pretty simple. In the simple linear regression, you have only one independent variable. Multiple, you have more than one independent variable. Fine. Okay. And here, okay. The idea here is, right, before we jump in further, one second. Here in this case, okay. Yeah, here we have this called your simple linear regression, right? That's why this arrow says. And here, let's the y, okay, your y is equivalent to, let's say 50,000 is your intercept value, okay. The 50 you are getting something like 50,000. This is calculated by your model, okay. So this is called beta naught, okay. And the and beta 1 is for example slope, okay. The slope, okay, the slope is 200. This is also calculated by model into size of the house. For the size of the house is less than 1,000 square feet. So how much you will get? 250,000, right? This is called y hat. Okay, y hat is nothing but predicted value of y. What is predicted value of y here? Is nothing but predicted price. Housing price. Predicted housing price is 250,000. How did we get this predicted value? By plugging in the intercept slope value and then the corresponding independent variable or the input feature value. So this is nothing but see this 1,000 is size of the house. This is independent variable. This is your slope. Nothing but beta 1. This is your intercept. Beta naught is your intercept. Is it clear? So intercept is given by my model when I train. I'll show you the example in the hands-on so that you'll be able to understand. Okay. This is calculated by the model. We don't have to worry about that. The slope also calculated by model. That's all. And behind this, it plugins all the values. Okay. It goes to your data set and it goes and picks up the first value of the size. Okay. The first row 1,000 is there. 1,000 into 200 plus. So ultimately you get 250, 250,000, the cost of the house. And then automatically, let's assume that in your data set you have 10 records, right? 10 different houses. In the second record, you have 2,000. Okay, instead of 1000, 2000 will come. 2000 into 200 plus this 50,000. That is what your predicted housing price for the second record, second observation data set. Got it? So now the question is, how did I get this beta naught and beta 1 value? So are there any formulas available? Yes, though you don't have to, though you don't have to manually compute it. It is computed by the model, okay, the statistical software, the beta naught and beta 1. We don't have to calculate it manually. But still, you should be knowing the formula for this and what formula that we use it in beta naught and beta 1, okay? So that it will be, easier for you to understand the underlying thing, okay? Got it? Okay, what is the formula for the intercept and slope? And what exactly intercept is all about? What exactly intercept is all about? One second. Sorry. What intercept? See, this is what my, if I visually look at my linear regression equation, y is equal to beta naught plus beta 1x. This is a mathematical thing. It's boring, right? For example, I want to visualize it using a chart. This is what my independent variable. This is what your y. This is your housing price. Okay. Dependent variable input feature. We plotted in these two different axes. Okay. And here, let's say you have some data here. Okay. Here and here and here and here and here. When you draw a straight line in such a way, all these values are as close to as many data points as possible. Okay, this is closer to this and this is closer to this. Fine. Okay. Yeah, maybe right. We could have drawn a line something like this, like this. Okay. Yeah, this line seems to be good, right? Because this line is good to this one and this one also, and this one it becomes too far. Correct. So obviously this one looks good, right? So basically, to obtain a best fit line in your linear regression model is your ultimate goal or your objective. Okay, that is what this one. And visually, when you look at this, the best fit line where it intersects the y-axis. Okay, this is y-axis. That is called your intercept. The line which touches the y-axis is called your intercept. Okay, and what exactly slope? Slope is something like this. Okay. Wait, 1 second. Sorry, I'm feeling sleepy. Okay. So, what exactly slope is all about? Yeah. Any example for this? Okay. So, y is nothing but, sorry, not y. Yeah, the line which touches the y-axis called your intercept. So, which is nothing but your beta naught. I just write the equation once again. Y is equal to beta naught plus beta 1x. And here this is the intercept. This is your intercept. This is nothing but this one. The line which touches the y-axis called your intercept. Okay, fine. What is beta 1 here? Beta 1 is a slope. Okay, what exactly slope is all about? Okay, the slope is yeah, intercept. Now we understood beta naught. And this is your beta 1, which is nothing but your slope. And here, in linear regression, it represents the rate of change in y. for a unit increase in, this is very important, guys. For a unit increase in dependent variable. Dependent variable. I just abbreviated because here we don't have space. Okay, dependent variable. So slope is nothing but the rate of change in y when a 1 unit increase in x. Okay, in yeah. So the rate of change in y for a unit increase in independent. Sorry, this is not an independent. This is independent variable. Okay, independent variable. Okay, independent variable. Okay, rate of change in y when x changes when rate of change in y for a unit increase in x changes. Okay, or independent variable. Okay, independent variable or the feature. So what exactly this one tells, guys? So this is where you get confused. The rate of change in y for a unit change, increase. Obviously, right? For example, if it is a 500 square feet of the house, this is square feet. The price is somewhere here. The price is somewhere here. When it is going to be 1,000 square feet, the price will be somewhere here, right? The price will be somewhere here. That's what is square feet. Let's say if it is going to be 2,000 square feet, obviously your y value change. As the value of x changes, the y also changes. Y also changes. So when you draw a line like this, right? For example, when you draw a line and vertically and horizontally where it gets intersected, right? So this is where it got intersected. So if for 2,000, the 2,000 square feet house, it costs something like, let's say 3 crore. Okay. So the estimated price, when the size of the house is 200 square feet, the estimated or the predicted housing price is, let's say, 1.2 crore. Okay, as the value of your square feet increases in your X, right? Obviously, the price also increases. It goes up. The price is increasing. Okay. And what the slope tells us is how much the Y will change when X changes. If I say 501 square feet, so how much your Y will change? Is that going to change in 2 times or 3 times? Or, can you quantify how much it will change the Y? Okay, so that is what I mentioned. The slope is nothing but the rate of change in y for a unit increase in the independent variable, which is nothing but the square feet of the house in this example. So now we understood what is slope, what is intercept, everything. What is the rest of the things we should be knowing it? Yes, error. So now we are clear. So in this equation, we understood what is intercept, what is slope, and we know what is independent variable, x, and we know what is dependent variable. Okay, we know everything. So, but we don't know this. Plus, we have another thing called, E error. We don't know what exactly error is all about. The same diagram, if you see here, I just redraw it here so that you'll be able to see it very clearly. Bear with me, I'm not good in drawing. And this is X. Okay, this is nothing but your size of the house. This is the price of your house. Housing price. Okay. And here, the size and price. For example, here you have some value. And here, so when you plot both the price and size in a chart, it looks something like this. So in this case, the best fit line is somewhat, it will come here, okay? Now it is very much unbiased to these two. So this is closer to this value. This circle is nothing but the value, okay? This value is closer to this line. Even this one is also closer to this one. Had I drawn a line somewhat closer to this one, obviously these values are very close to the line, but the other rest of the values will fall too far from that line, isn't it? So we need to draw an unbiased line. This is called your best fit line. The predicted value will lie on top of this one, the best fit line. Okay. So the objective of linear regression what is to obtain the best fit line. Once you obtain the best fit line, see all the predicted values will lie on top of this line only. See here for this corresponding value, there is another. This is what your predicted value. Sorry, the predicted value. This is your actual value. This is your actual. This is your predicted. Okay. So the objective of the fitting the best fit line is to to minimize the error between actual and predict. This is your actual size of the square feet, and this is the predicted. Sorry, this is the actual size of your. Sorry, this is your actual price, and this is your predicted price. Okay, this one is your predicted price. This one is your actual price. What is the difference between actual price and predicted price? Okay, that is called your error. The error can be negative value also. Okay, not necessarily it has to be positive. Okay. It can be negative also, but to suppress the sorry, to prevent subtracting the negative value from the positive value of your error, we are squaring that value so that we will get to know the magnitude of the error, right? So how much error is there? If you have a negative error along with the positive error, the plus and minus will get subtracted. And end of the day, you'll think, hey, the error is less. My model accuracy is good. Okay. Yes. See, the objective is you want to fit the best fit line, right? You want to fit the best fit line. We don't have to draw the line manually. It's all taken care automatically behind the scene. But if somebody is asking you, what is the underlying idea behind this, right? The objective of the linear regression is to fit a best fit line. இதனுடைய நோக்கம் என்னன்னா ஒரு பெஸ்ட் ஃபிட் லைன் வரணும். அந்த லைன் என்னன்னா இந்த வேல்யூக்கு பக்கத்துலயும் இந்த வேல்யூக்கு பக்கத்துலயும் இருக்கணும். அதுக்கு அந்த மாதிரி ஒரு லைன் போடணும். இந்த வேல்யூக்கும் பக்கத்துல இருக்கணும், இந்த வேல்யூக்கு பக்கத்துல இருக்கணும் அந்த லைன். இப்போ இந்த லைனை வந்து இதுக்கு மேல போட்டா என்ன ஆகும்? இந்த லைன் எக்ஸாக்ட்லி ஆல் தீஸ் வேல்யூஸ் வில் பி ஆன் டாப் ஆஃப் தி லைன். அப்படி இருக்கக்கூடாது. ரைட்டா? அப்போ என்ன ஆகும்? இப்போ இந்த லைன் இஃப் ஐ பிரிங் இட் டவுன் ஹியர், ஸோ வாட் வில் ஹேப்பன்? இட் வில் பி குட். But these values will be too far from that line. இப்போ இங்க ஒரு லைன் தான் என்ன ஆகும் actually? It will be too far for this value, right? See, something like these are houses in a village, right? எல்லாருக்கும் பக்கத்துல இருக்கிற மாதிரி ஒரு ரோடு போடணும். இந்த மாதிரி போடுறோம். இந்த ரோடை நான் இங்க போட்டா என்ன ஆகும்? இவங்களுக்கெல்லாம் ரொம்ப பக்கத்துல இருக்கும். இவன் எல்லாம் என்ன பண்ணுவான்? சத்தம் போட ஆரம்பிச்சிருவான். அவங்களுக்கு மட்டும் பக்கத்துல ரோடு இருக்கு, வீட்டுக்கு பக்கத்துல எங்களுக்கு ரொம்ப தூரமா இருக்குன்னு சத்தம் போடுவாங்க இல்லையா? அதனால இவனுக்கும் பாதகம் இல்லாம இவனுக்கும் பாதகம் இல்லாம நடுவுல ரோடு போடுறோம். ரைட்டா? ஒரு என்ன சொல்றது, ஒரு நடுநிலைமையில் இருந்து நாம் ஒரு ரோடு போடுறோம். அப்ப என்ன ஆகும்? இவனுக்கும் தூரமா இல்ல, இவனுக்கும் தூரமா இல்ல. 2 பேருக்கும் பக்கத்துல பக்கத்துல இருக்கு. ஆனா 2 பேருக்கு வீட்டுக்கும் ரொம்ப பக்கத்துல இல்ல. பக்கத்துல பக்கத்துல இருக்கு. ஆனா ரொம்ப பக்கத்துல இல்ல. ரைட்டா? ஸோ திஸ் காட் யுவர் பெஸ்ட் ஃபிட் லைன். ஸோ இந்த பெஸ்ட் ஃபிட் லைன் மேல தான் இந்த ப்ரிடிக்டட் வேல்யூ இங்க இருக்கும். ஸோ திஸ் இஸ் யுவர் ஆக்சுவல் வேல்யூ. 1 செகண்ட். ஸோ திஸ் இஸ் யுவர் ஆக்சுவல் வேல்யூ. அண்ட் இங்கே போனோம்னா திஸ் இஸ் யுவர் ப்ரிடிக்டட் வேல்யூ. இந்த ப்ரிடிக்டட் வேல்யூங்கிறது இதுதான். ஐ ஜஸ்ட் கலர் திஸ் வாட் ப்ரிடிக்டட் வேல்யூ, திஸ் யுவர் ஆக்சுவல் வேல்யூ. The difference between these two are called your error. Got it? இந்த ஈக்குவேஷன் எல்லாத்துக்கும் மீனிங் தெரிஞ்சு போயிடுச்சா? So all of you are able to understand the each component in this equation. You got an idea. So what is beta naught is nothing but your intercept, and what is your beta 1? Beta 1 is nothing but your slope. Okay, intercept and slope. and E is your error. What is the difference between actual and predicted value? Actual and predicted value. So actually, for example, to paint my entire apartment, how much I incurred? For example, 10 lakhs. How much we predicted? Almost 9.6 lakhs. These were actual, these were predicted. Subtract panna enna agum? We'll get 0.4, right? This is what the error. Because நம்ம 9.6 lakhs தான் செலவாகும்னு நினைச்சோம். ஆனா நிஜமா ரியாலிட்டியா என்ன ஆச்சுன்னா, இன் ரியாலிட்டி 10 lakhs ஆயிப்போச்சு. அப்போ ப்ரிடிக்ஷன் எரர் என்ன? நம்ம கம்மியா ப்ரிடிக்ட் பண்ணிட்டோம். We have under predicted. Actually, it was 10 lakhs, but we under predicted. But the error is not, too high. இதுவே வந்து இப்போ வந்து ஃபார் எக்ஸாம்பிள் 2, 5 எல்லாம் இருந்ததுன்னா எரர், higher the value of error represents the predicted value, is not accurate. For example, here, okay, in let's say we have predicted something like 5.8 lakhs. அவ்வளோதான் ஆகும்னு நினைச்சோம் பெயிண்டிங்க்கு. ஆனால் 10 லட்சம் ஆகிப்போச்சு. அப்போ என்ன டிஃப்ரென்ஸ்? வாட் இஸ் த டிஃப்ரென்ஸ் பிட்வீன் 10 lakh அண்ட் 6 lakh வச்சுக்கலாமே? 4 lakhs டிஃப்ரெண்ட் இருக்கு. ஏன்பா உன்னை ப்ரிடிக்ட் பண்ணி சொல்லுன்னு சொன்னா 4 லட்சம் ரூபாய் வித்தியாசத்தில் சொல்லியிருக்கிறேப்பா. ரைட்டா? கரெக்டா? அந்த மாதிரி தானே சத்தம் போடுவாங்க. They will tell you that way, right? So the accuracy instead of 4 lakhs, ஓகே, இங்கே இப்போ எனக்கு 9.6 lakhs நான் சொல்லியிருந்தேன்னா மேனேஜர் கிட்ட, சார் இதுக்கு எல்லாத்துக்கும் பெயிண்ட் பண்ணுறது 9.6 lakhs தான் ஆகும். பட் என்ன ஆச்சுன்னா, கொஞ்சம் அங்கங்கே டேமேஜ் கொஞ்சம் எக்ஸ்ட்ரா இருந்ததுனால we had to spend little more money. ஸோ ஓவரால் தி ஆக்சுவல் அண்ட் ப்ரிடிக்டட் இஸ் மோர் ஆர் லெஸ் சேம். 10 lakhs ஆகிப்போச்சு கையில் இருந்து. ஆனால் அவன் சொன்னதும் 9.6 லட்சம் தான் ஆகும்னு சொன்னான். ஆனால் 10 லட்சம் நான் செலவு பண்ணிட்டேன்ப்பா. அப்படின்னா என்ன அர்த்தம்? ஸோ ப்ரிடிக்ஷன் எரர் எவ்வளோ? The prediction error is 0.4. Supposing, even this scenario could have happened. நீங்க வந்து பார்த்தா, ஸோ 11 lakhsன்னு மாடல் ப்ரிடிக்ட் பண்ணியிருக்கோம். பட் ஆக்சுவலாக 10 லட்சம் தான் இருக்கு. நம்ம எவ்வளோ எதிர்பார்த்தோமோ அதை விட கம்மியாக தான் செலவாயிருக்கு. ஸோ இஃப் யூ சப்ட்ராக்ட் தி ப்ரிடிக்டட் வேல்யூ 11 lakhs from the actual, -1 we are going to get. Okay, this is your error. இதை நம்ம ஸ்கொயர் பண்ணணும். -1 squared, -1 into -1 +1. Is it clear? So now we understood what is beta naught, beta 1x plus error. Now, right, these values beta naught and beta 1 will be calculated and given by your statistical software, something like scikit-learn package. You have something called linear regression model, or it will give you everything. Okay, this is your data set. Okay, this is your size of the house in terms of square feet. Now we understood what is beta naught, what is beta 1, and what is x, and what is error. Okay, and now I just go to the my Python, Jupyter notebook. So now we understood what is objective of this one. Objective is fitting the best fit line. Don't get confused too much. Okay. So now we know what is NumPy package. I explained you about NumPy, and we have seen how to create an array, matrix, everything using NumPy package, and pandas, using pandas, how to be slice the data. Okay, we can use pandas package to perform SQL-like operations, like if you want to join more than one table, if you want to perform left outer join, right outer join, right, everything is possible with pandas package. Okay, and Seaborn is a visualization tool, package, using which you can plot the charts. So these two are data visualization related tools. Okay, charts, if you want to create charts, you can create the chart and you can see it. everything, okay, using the chart, okay. But anyhow, here I did not use any chart. One second, I just go, yeah, here I did not use any chart, okay. So last one was chart, that one got created automatically. So here I'm going to import all the machine learning models, sorry, the packages, not the models, packages, okay. And this is related to data visualization. These two are related to perform the numeric operations, okay. And the last one is your scikit-learn. It is called your scikit-learn. I just people used to pronounce it something like scikit-learn. Some people they say sklearn. All these two terms are same when it comes to the package name, okay. Sklearn dot linear. This is what my package name. In that I have a sub package called linear model. From there I am going to import the linear regression because I am going to train a linear regression model only, because we are talking about linear regression only so far, isn't it? Okay. The sklearn, yeah, package, and linear model is the sub package of this package. And from here we are importing the linear regression, using which we are going to train the linear regression model. The next one is, once you train your model, you want to check the accuracy of the predicted values by your linear regression model. For that, we will be using some metrics using which we can evaluate model performance. Okay, enough theory. Okay. Next one is, look here, I'm going to read this housing data.csv file. It's a comma separated file. And I just used the data frame htf.85, which means display only the top 5 records in your data set. In this data set, it's pretty simple, isn't it? We have size, undivided share, parking lot, MISC, and price. And here, these four, the size, UDS, park, MISC, okay, or your input features. Okay, one second. These four, sorry, 1 second, I just made a mistake. So these four are your independent features or the features. The housing price is your dependent variable, rest of them are independent variable. Got it? Okay, here we have three input features and one outcome variable called price. And I am going to say this one, the data file, CSV file, I'll read it. I read this data file and then I stored the data in a variable called HDF. This variable is now your data frame. Okay, PD stands for pandas dot read CSV. This is a function or the method that is available as part of the package pandas. And here you need to specify your file name and path name and separator also. Okay, and if I type htf.8, it displays top 5 records from this data set. Okay, and here the size, UDS, Spark, MIC, these are independent variable. Price is your dependent variable. And how do I find out the total number of records and columns in a table, pandas table? For that, shape command. This is very much important. One of my students, right, they asked this question, he was not able to recollect. So when you execute this note, you see the output something like that. That means 148 rows are there and 5 columns are there. Got it? Okay. So now you understood what are the in the input features or the features, size, UDS, Spark, MISC. These four are your input features, and the price is your dependent variable. Okay, fine. And next one is, see here the get 5. What it does is it will display only the first 5 records of your data frame HDF. Okay, that is why it is showing like that. Okay, next one is the pair plot, using which we are going to check, are there any correlation exists between the independent dependent variable. Okay, I just do one thing. I just go here and execute everything. So you can see the star here. That means you need to wait for some time because these packages are getting reloaded. Okay, and next step is STF is your data frame. Now shape gives you this one, and next one is 1 second here. I just read it everything so that it will display everything. No more confusions. Till the star you can see that means still it is in progress. So whatever you have understood theoretically, we have implemented it in a Jupyter notebook. Okay, the algorithm. Okay, here you have something called pair plot. It will show are there any correlation exists between or amongst these independent variables itself. Your input features, which is nothing but your independent variable, uh, you know, your independent variable. These are called your independent variable: size, UDS, spark, MIS. Okay, and the next one is the price. This is your target variable, dependent variable. Okay, the price is depending on these factors. Yeah, but as a data scientist, we should be in a position to find out which features are statistically important. Still, it is executing it. Let's wait for a few seconds. Okay, until this star gets disappeared, we will have to wait. Let's wait for a few seconds. Man, still it is going on. Okay, it's something unusual. What I am going to do, I am going to click on this square kind of thing. Can you all say it? The interrupt the kernel? Okay, okay. Even here itself some issue happened. Okay, before even I interrupted. So yes, that no such file or directory. Okay, e dat one housing data. This directory itself not there. 1 second, I need to change it to capital E. But in my hard disk, I don't have E drive. Sorry, D drive. But I have E drive. I'm going to read. That's why it was throwing an error. Now in E drive, in this folder, housing data.csv file is out. That's why we can see this one. And I'm going to execute this shape and pair plot. SNS.pair plot. Why it takes this much of time, man? For visualization, it takes longer time. What happened here? Still it is going on. Okay, okay. Yeah, look here. Very good. So now it got executed, right? Pair plot. So using the C1 package, there is a method called pair plot. Here you need to specify the data frame and your x-axis values, y-axis values, and kind equal to reg is your regression, and these are size and aspect. Okay. Once I executed this command by clicking on it here, I can see that the chart got displayed here. And in this chart, in the x-axis, you can see all the x-axis related columns here. Y-axis, the housing price. For example, size of the house and price is also correlating, yes. And UDS and yeah, and this one. sorry, the UDS and housing price, okay? This is one independent variable here. This is another independent variable, independent. So we have more than one input features. You are comparing each and every input features with our target dependent variable. In this case, it is a price. Are these two columns or quantitative variables are correlating with each other? Yes, we can see that there is a straight line going on as close to as many data points as possible. But whereas here, if you see that the best fit line is there, still the values are scattered here and there. But here, if you see, it is almost tilted, right? It is about to fall down and it will become flat. Okay, so that means these two variables, size and price, are having higher correlation, linear correlation, higher linear correlation. The UDS and price, these two features are having it exists relationship, okay, correlation. It exists. There exists a relationship between the UDS and price. Next one is parking lot and MIRC. These two are not a straight line. Okay, hence it got tilted like this. Okay. So what we are concluding here is to train a machine learning model, especially the linear regression model, both the input feature and output feature should have the correlation. Okay. But here the size and UDS, these two columns are having higher correlation with your price. Rest of the two columns are not at all correlating with my housing price. In that case, why should I include these two sorry, these two countries, right? What we'll do is we will, yeah. So here, this is one of the mandatory thing, okay? All the independent variables should be linearly correlated with your dependent variable. I think all of you are feeling sleepy, heavy food. See, y is equivalent to beta naught plus beta 1, beta naught plus beta 1 x. Y is disappearing. Okay, sorry. Y is equal to beta naught plus beta 1 x. Okay, which is nothing but y is equivalent to your intercept plus slope into x. Okay. So intercept slope, we already got that value. And x is your independent variable. Let's say this is the size of the house. But here, both the independent and dependent variables should be linearly correlated. This is for nothing but an housing price. Both these variables, the x and the independent variable or input and output should have a correlation. How do I find out? By fitting that in a chart. We can make out quickly visually. How do I make out visually? These two columns, the size and UDS, these two columns are highly correlated with my housing price because it fits the data nicely. Though there are some outliers here, but still, align it. But here, the majority of the values are gone out, too far from your line. And same is applicable here also, right? Majority of values are going too far from, but whereas if you see, right, anything above this, we don't see anything, right? But here, you can see, many values are. So with that, we can understand, these two variables, price and MISC are not correlating with your housing price. Hence, in our regression model, we have to include only these two independent variable, size and UDS. Got it? So what is the rule of them? Rule என்ன? ஒரு ஃபீச்சர்ஸும் இன்புட் ஃபீச்சர்ஸும் அவுட்புட் ஃபீச்சரோட காரிலேட் ஆயிருக்கணும். Fortunately, here all the input features are numerical value. Okay, see size, UDS, spark, MAC, இது எல்லாமே numerical value. So we are comparing size with the price. Price is your outcome variable. This is the input feature. We are comparing the input and output feature with the correlation. Yes, there is a strong correlation exists with size and price. Hence, we can include that in your linear regression model. Okay, and UDS and these two also having higher, a relatively higher correlation. Hence, we can retain UDS, but these two variables are nonsense because these two variables were not correlating well with my target variable price. Hence, we can drop these two columns. So in this case, the pair plot rule is, really crucial, is really good. And next one is the correlation. There is something called correlation. So using which also you can find out. So this is your scatter plot. Okay, this is your kind of the correlation plot. Here I'm using, this is my data frame name, dot cor function. This is the one will give me the correlation between each and every independent variable with respect to their outcome variable. Okay, so it gives me for each and every record, right? It gives me the correlation. Are these values are correlating with me? Give me the correlation values. Yes, correct, correct. Give me the correlation. So core function is readily available, and I'm going to use a heat map function that is available as part of Cborn. And here the first argument, look here, and I'm going to I have passed this thing directly here. So here is something like this. Okay, I just use some simple analogy. For example, in a family, both husband wife are living. Are they, if somebody's, are there any relationship exists between these two people? So one guy is there in a house, and along with him another lady is there. Do they have any relationship? Yes, they have relationship. How, the next question is how strong the relationship? Both of them are living in the same house, but are they really closer to each other? No. Just for the namesake, they are living as an husband wife. You just think that way. Guys, don't get me wrong. This is just for an example. Okay, if somebody is asking you, do they have relationship? We say yes, because I could see them, for the last 3 months, they are living in the same house. Just because two people, husband wife living in the house, that doesn't mean they are so, what do you say? They are so close, right? To quantify that, yes, there exists a relationship, linear relationship, but how do I quantify that? To quantify that, we use correlation core function, COR function that plots the values here. For example, here in this case, so here in this case, one second, the price, right? The price and size, these two correlated very well. Okay, these two have correlated very well, right? Sorry, not the thing. Okay, so the price and size are correlated well. So there exists a linear relationship, these two variable. But is it possible to quantify the relation? Yes, 0.8. That is what correlation. Using correlation, you can quantify the strength of the relationship. Yes, 0.8 இருக்கு. And similarly, if you see here, the undivided share and the housing price, both of them are correlating well, right? Even this one and this one, both of them are correlating well with my target variable or the dependent variable price. Okay, the size is correlating well with my dependent variable, and UDS is my input feature. Even this one is correlating well with this one. So based on this value also we can say very clear, right? So what is 0.8 and 0.56? The correlation value, we use a notation called R. The correlation values should be anywhere between 0 and 1. Any value which is closer to 1 is called your higher correlation. Okay, and here 0.8 is closer to 1, hence the size and price are correlating very well. And this guy, right? Yes, here 0.56 also reasonably, somewhat closer to 1, right? So we can say these two variables are helpful in terms of predicting the housing price. By finding out the correlation, we can right, finding the correlation between the dependent and independent variable, we can make sure that which all variables input features are helpful in terms of predicting also which variables or which features are not input features not helpful. These two are useless because 0.2, 0.2 only is there, right? If you see the parking column or the input feature with your price, the relationship is just zero point 0.2, whereas here 0.56, here 0.8. Hence, don't include these two columns in your model to predict the housing price because these two variables are not at all correlated with my target variable. So the rule here is each independent variable should be correlated well with your target outcome variable. Yes, we have seen so far. This one I walked through this code, right? Next one is I'm going to use a variable called features. On the right side, I have created a list, and in this case, right, I keep only the independent variable or the input features in it. Size is an input feature, UD is input feature, and so on. I put all the input features in the variable called features. It's a list, right? I'm going to pass the features list to this data frame so that size, UDS, spark, MISC, only these four columns values will get stored in a variable called X. Next one is the price. So right. In fact, we have five columns were there. Four columns are in input features. Only one column was the dependent variable. This one we store it in another variable called y. So now we are pretty clear, guys. X variable contains all the independent in or the input features. Y variable contains the dependent variable price, value of the dependent variable price. Okay. Now, if I see that, right, what value is stored in X, print X, if you use it, you can see size and UDS, only these two columns. See, look here, I just, include only size and UDS, I, excluded park and MISC. Now, if you see here, size and UDS column are available in STF data frame. And, here we can see only two values. Okay. And, the other one is your price. Okay. So now what we are going to do, the next step is we are going to split the data into training and test data set. So what did we do so far, guys? We have loaded the data in my Jupyter notebook, and then what did we do? We just checked, the first top five records, and then we moved on with, creating a chart using the pair plot. Pair plot helps us to understand how each independent variables are correlated with my outcome variable or the output feature housing price. In this case, size and UDS only. These two input features are correlating well with my housing price. Okay, to see the strength of each correlation value, you can use the core function. Okay, core function, and then here I just use directly the HDF dot core inside the SNS dot heat map function. Unknown equal to true. What is unknown true? It will display the values, the correlation values. Okay, annotation equal to true, and plt dot show your plot is ready, and here it shows all the independent variables like size, UDS, spark, MAC, and price. In the y-axis also same thing, and only these two variables, size and price, are having higher correlation, and UDS and price have the higher correlation. Okay, now we understood, right? So here the next step is we need to split the data into training and test data set. So why do I need to split the data as training and test data set? Using the training data set, we are going to train our model. Once we train our model to evaluate or to check how well my trained model is working. For that purpose, we are going to have the test data set. We are going to divide the data into training and test data set. What ratio are we dividing it? Here we have an option called test size in your train test split function on the right side of your equation. Okay. And here you can specify 0.3, 0.5. That means, let's say if you are specifying 0.4. So in the given data set, 40% of data use it for testing purpose. Remaining 60% data you can use it for training purpose. That is what it says. Okay. And again, I'm going to see print x train shape and x test shape. It says after splitting this 111, comma 2 and 37, comma 2. Okay, next one is the core part, the training the linear regression model. So the linear regression method or the function is available where? that is available sklearn linear model. This one, this method, sorry, this is the class, right? This class is available as part of my sklearn package. We have, initiated this session here, okay? And then look here, this is the one we initiated with this init fit variable. So in the next line, init fit dot fit, there is a function called fit. Remember this. So, right? And then here, I mentioned about all the independent variables and then the dependent variable value. And then that's all. Init dot fit, what it'll do is it'll fit the linear regression model. Now it has been done in one liner. Okay, here I need to click on this one and then only I should have done it. Okay, here it says X is okay, okay. You need to go up here. Okay, and here I will click on this one. I am going to execute this one also. Yes. So in the training data set, we have 111 records. In test data set, we have just 37 records. Usually the training data set will be more compared to your test data set. We have splitted the given data into training and test split. With this 111 data set, the trained data set, sorry, the data set 111 is available as part of your X train variable. Okay, so we have sufficient amount of the values for the training purpose, and then the fit function will train your model. Once model get trained, if you want to see the coefficient value, I used to tell you this one, isn't it? Which one? The beta naught and beta 1 values will be calculated automatically by your model. See, y is equivalent to beta naught plus beta 1x. Plus the error term, you can ignore it. Beta naught and beta 1 already computed. So this is what your, this is what your, in this case, we have four independent variable. What is the equation for the multiple integration in this case? Beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 into x4. Okay. So in this case, the beta 1 and beta 2 and beta 3 and beta 4. These are called the slopes. These slopes are with respect to their corresponding the independent variable features. This beta 1, beta 2, beta 3, that is what. So the beta 1 is nothing but 0.44 and the beta 2 is nothing but 0.181 and beta 3. For each and every slope, it computes the value automatically. What is beta naught? Beta is the intercept. Even for intercept, it already computed the value 3.22, something like that. Plus your beta 1 x1 is, what is beta 1 x1? 0.04, right? 0.04 approximately. Okay, instead of putting all the things. And into your x1. What is the x1 is here your size of the variable, right? For example, 12 feet or 1200 feet. Multiply this and plus the remaining thing, same thing, okay, beta 2 x2. Beta 2 is your 0.189. Okay. Let's say the UDS size is 10 square feet. Okay, 10 square feet into this one. This is where the carpet area square feet. You multiply with this slope, and if you add this intercept, you will get the estimated or the predicted housing price. Simply the fit function is helpful in terms of training our model, right? The fit function or the method. Yeah, this is what I'm talking about it. Fit. Okay, the fit. I'm talking about this one. Fit is a method or the function using which we have trained our machine learning model using the training and test data set. Training data set. Using the training data set, we have trained our model using fit method. Yeah, in the same order, you need to pass the argument. Don't specify y underscore train first and x underscore next. That is wrong. You need to first specify your independent features and then only specify a dependent feature, different variable. Once you pass this value as an argument to this one, it gives me the model coefficient values. This is your beta 1, beta 2, beta 3, beta 4, and this is your beta naught intercept. Okay, we have trained our model. So what is so big deal? Okay, man, you trained your model. What is the use for me? We need to predict it, right? We need to apply this model on the unseen data. Model dot for that model dot predict x test. What is model? Model is nothing but the previously trained model. Just a while ago, we have trained a model, right? This is what this model is all about. Okay, the same thing. Yeah, we have seen it here. Okay, so here model dot predict. So this is the model we trained it. Now we need to apply this trained model on the unseen data. For that purpose, model dot predict function test data. The data frame is mentioned it here. And then if you once you execute this, you can see the predicted housing price for the unseen data test. And the next step is okay. Now we have trained our model using the training data set. Next one is we need to evaluate the model performance. In this case, we need to evaluate your model with your test data set. Okay, I think you guys are feeling bored. Am I correct? Are you able to follow me so far? Yes, yes. If you are not able to follow me, you can watch my video one more time, okay? Okay, next one is, see, something like training the model and then testing the model. ஒன்றும் இல்லை இப்போ நம்மளுக்கே இப்போ சொல்கிறாங்க இந்த 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 டபுள் பெட்ரூம் இருந்து ரெண்டு பால்கனி இருந்து ரெண்டு கார் பார்க் இருந்தால் இதான்ப்பா ஹவுசிங் ப்ரைஸ் சொல்கிறாங்க சரியா நாம் என்ன பண்ணுறோம் இன்னொருத்தர் நம்மக்கிட்ட கேட்குறாரு இது நம்ம ஏற்கனவே தெரிஞ்சுக்கிட்டு 4-5 பேர்கிட்ட கேட்டு அது ஹிஸ்டாரிக்கல் டேட்டா அவர் மெயின் காட் ட்ரெயின் நாம் இப்போ ஒரு மிஷின் லேர்னிங் மாடல் ஆகிட்டோம் இப்போ என்ன இன்னொருத்தர் கேட்குறாரு சார் இந்த இந்த ஏரியாவில் லெட்ஸ் ஆல்மோஸ்ட் ஒரு 1900 ஸ்கொயர் ஃபீட் இந்த அன்டிவைடட் ஷேர் 600 ஸ்கொயர் ஃபீட் இருந்தால் என்ன ஹவுசிங் ப்ரைஸ்ன்னு கேட்கும்போது எனக்கு என்ன ஆகிப்போயிடுது ஓ இதே ஸ்பெசிஃபிகேஷன் தான் இப்போ ரீசெண்டாக விற்றாங்க மேபி அது 1.8 crore இது மேபி பிட்வீன் 1.6 to 1.8 crore யூ ஹேவ் டு ஷெல் அவுட் சார்னு சொல்கிறோம் இல்லையா ஸோ இந்த கேஸில் என்ன ஆகுதுன்னா அந்த ரேஞ்ச் ஆஃப் வேல்யூஸ் யூ பட் ஸ்டில் வாட் இஸ் த ஆக்சுவல் வேல்யூ ப்ரிடிக்ட் பண்ணி சொல்கிறோம் பட் ஆஃப்டர் 1 year கழிச்சு வீடு விற்க போகும்போது ஸோ 1 crore 1.3 crore கேட்குறாங்க பட் நாம் ப்ரிடிக்ட் பண்ணது 1.2 crore தான் நான் வி அண்டர் ப்ரிடிக்டட் ஓகே that is a mistake there is an error okay there is an error so next okay you இப்போ 10 lakhs is the current price of the house after 5 years what is the price you say something like 15 lakhs your brain got trained and if somebody gives you any specific you can tell you this is the estimated or the predicted housing price okay now the question is what is the assurance that whatever the value you are saying is correct. Is there any way, can I evaluate it? Yes, that is where the test data. We are going to apply the trained model on the test data set to make a prediction. Okay. So if the error is less, the accuracy is more. This is common. Across machine learning, deep learning, all algorithm, if somebody asking you, if the error get reduced, what is going to happen? The accuracy is going to improve. 10,000 ரூபாய் சொல்கிறான் பெயிண்ட் அடிக்கிறதுக்கு அது ப்ரிடிக்ட் பண்ணி சொன்னான் ஆக்சுவலாக எவ்வளோ ஆச்சு 11,000 ஆச்சு. அப்போ 11,000 is your actual, 10,000 is your predicted. 11,000 minus 10,000 plus 1,000. ஃபார் எக்ஸாம்பிள் 11,000 வந்து செலவு பண்ணியிருக்கோம். ப்ரிடிக்டட் வந்து 10,800 சப்ட்ராக்ட் பண்ண பாயிண்ட் அப்போ 200 ருபீஸ் தான் டிஃப்ரென்ஸ். ஸோ லெஸ்ஸர் த எரர்னா என்ன நினைக்கிறோம், கரெக்டாக தான் ப்ரிடிக்ட் பண்ணியிருக்கான்ப்பா. ஆல்மோஸ்ட் வந்து ₹200 தான் வித்தியாசம் இருக்கு. அவன் ப்ரிடிக்ட் பண்ணதுக்கும் நம்ம கையிலேருந்து செலவு பண்ணதுக்கும் ₹200 தான் வித்தியாசம். அப்படி தட் மீன்ஸ் ஹிஸ் ப்ரிடிக்ஷன் அக்யூரசி வாஸ் குட். அதை விட்டுட்டு ₹10,000 வந்து சொன்னோம், ₹10,000 செலவாயிடுச்சு. ஆனால் அவன் சொல்லும்போது ₹5,000 தான் சொன்னான். ப்ரிடிக்ட் பண்ணும்போது இப்போ எஸ்டிமேஷன் கொடுக்கும்போது ₹5,000 தான் சொன்னான். ஆஃப்டர் வி கம்ப்ளீட் த பெயிண்டிங் வி பெய்ட் ₹5,000 மோர். 5,000 பிக் நம்பர். 200 பெருசா, 5,000 பெருசா? 5,000 பெருசு, right? 5,000 is bigger than your 200 rupees. Previous example we have seen 200 was the error. That means lesser the error, better the prediction accuracy. This is the rule of thumb, you need to remember it. So next one is we have something called the root mean squared error. Okay, here there is a function called mean squared error that is available as part of our sklearn.metrics package. இங்கே போயிட்டு you need to specify your test data set, the dependent variable values, and then the predicted dependent variable values. Okay, so you need to pass the actual and predicted value from the test data set to get your mean squared error. And here இது வந்து root mean squared, இது வந்து RMSங்கிற வேரியபிள் ஸ்டோர் பண்ணியிருக்கேன். This what your RMS, root mean squared. Here I'm taking the square root on the mean squared error of both the actual and predicted values of your test data set. அப்போ என்ன ஆகும்னா, this one gives me an error, root mean squared error. If the error is very less, then your model accuracy is good. யூஸ்வலி என்ன பண்றோம், ஒரு 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 காரை பில்ட் பண்ணிட்டோம், ஒரு காரை வந்து நம்ம ப்ரொடியூஸ் பண்ணிட்டோம், அடுத்து நம்ம டெஸ்ட் பண்ணணும் இல்லையா? அதே மாதிரி சிமிலர்லி ஒன்ஸ் யூ ட்ரெயின் யுவர் மாடல், யூ நீட் டு இவாலுவேட் யுவர் மாடல். That is called your test. So to evaluate the model, you need to have the separate data, is test data. It should be different from your training data set. Now I'm going to apply the train model, the unseen data, which is nothing but test data set. And then I'm going to evaluate this one using the test data set. And I'm going to check the RMSE value. If it is lesser, that means the model accuracy is good. So the exercise here is, right, so now you understood this script, right? Somewhat you understood. You need to execute each and every cell manually. But this data set also I will share it to you guys. And you need to change this folder name. For example, in your laptop you have D drive. You need to specify D drive and create one folder called dat1. In that you put this file which I'm going to send it. That's all. Okay. And then if you execute, it will get executed. You can see that the housing data.csv file content here, first file record, and then we are going to plot the input features with the output feature. Okay, so the size, how well it correlate with the price, and another UDS, how well it correlated with the price. That is what we are checking it here, right? So by looking at this itself, we can understand both the size and UDs are correlating well with my price. The rest of them are not, because the values are too scattered here. And again, the same thing we are going to look at different way in terms of we are quantifying the values in terms of correlations. So here also we can see that both the size and UDS have higher correlation values compared to your price. Hence, we decided to include only UDS and price. Look at UDS and size. Size and UDS, these two independent variables are highly correlating with my price. Hence, I'm going to include only those two columns, size and UDS, in my data set. Okay, remaining columns, I am not going to include it because those columns are not helpful. Right? Any questions so far? With this, I'm going to wrap up, guys. I think you are feeling sleepy. Even, today I'm feeling sleepy because today was a big day for me. I was attending another function, driving whole day. Okay, if you have any questions, you let me know. Okay, and yes, it requires time.